So today we'll be covering objects and classes. And first we're gonna cover inheritance and polymorphism. And then there's two rules that we're gonna learn about polymorphism. So the first one is what we're gonna cover later. So, okay, so single inheritance, the extends keyword is very important when it comes to inheritance. So inheritance allows one class to include all the fields and methods from another class. For example, here we have class student extending class person. And right, in this example, the class, which we covered last time, you have the class extending person. And so each student has an int age and a string name, and that's the field of the class. And then we call student the subclass and person the superclass. Okay, so inheriting methods. A subclass that also inherits all the methods from the superclass, unless these methods are marked private. The subclass can also access the superclass's methods. Okay, so looking at this code, it tells you how to overwrite a method in the subclass. You can redeclare a method with the same signature in the subclass. For example, here we have both person and student defining a getName method. So the method is called getName. And when you overwrite a method, the subclass method is run instead of the superclass's method. However, you can still create objects of the superclass type and run the superclass method. In this case, it's new person, parentheses. Okay. So constructors are chained. And what I mean by that is when you instantiate an object of the subclass, it still runs the constructor of the superclass. So take this example. In the above example, new student, parentheses, runs both the new person constructor as well as the new student parentheses constructor. So this is a subclass constructor, which must call the superclass constructor. And if you do not explicitly call the superclass constructor, Java will automatically call the superclass constructor with no arguments. Okay. So the keywords this, super, and super parentheses are very important. This versus super with fields and methods. So when a subclass overwrites a field, and again, like a field is a variable inside a class. So when a subclass overwrites a field or method of the superclass, it can become non-obvious whether coder refers to the subfield or superfield or submethod or supermethod. You can use super.fieldName to refer to a field in the superclass. Similarly, super.methodName parentheses calls method in the superclass. Alternatively, this .fieldName, right? This .fieldName using OOP, object-oriented programming, will pick the subclass field even if the superclass is the same name field. Similarly, this .methodName calls the method in the current subclass, and this example calls both in compare names. Okay, so within a subclass constructor, calling super invokes the superclass constructors. And again, the arguments are optional. But so when you call the superclass constructor, it must be the very first line of the subclass constructor. As you can see from the code example, but by default, a super parentheses with no argument is always present unless you replace it with your own. Okay, so again, I'm just going to repeat this slide real quick. So when you're explicitly calling the superclass constructor, okay, you have to make sure that the superclass constructor is the very first line of the subclass constructor. And by default, a super parentheses with no argument is always present unless you replace it with your own. So like how we talked about modifying this constructor last time. But every user-defined class is a subclass. So if a class does not explicitly extend another class, Java will automatically make it extend the object class. And this means that every instance of any class in Java is an object. Okay. And if you create your own class with no superclass, such as class student, then it subclasses object. If, however, you extend another class, such as person, where person extends object, then student is also an object. The toString method. So although the Java class has many methods, hold on, let me just put this. Okay, so yeah, the most often used is the string toString method. This method is used by system.out.println to convert an object into a string. In other words, overriding this method changes what gets printed when you print the class. Okay, now that was just an intro about inheritance, some basics, extending classes, constructors. Now we're going to cover polymorphism, and this is the heart of Java. Okay, this is a relatively difficult concept. Okay, so reference types must be superclass of object types. And I'll say that again. Reference types must be superclass of object types. Consider the following valid program. So person X is equals to new student parentheses is valid, even though the left-hand type and right-hand type are not equal. And we call the left-hand type the reference type and the right-hand type the object type. The left-hand type refers to what type X is. So I know that was a little disorienting, but person X, so person X equals to new student, and the left-hand type, right, in this case is person, and the right-hand type, right, in this case is student, they're not equal, right? So that's a little confusing to some of you. That could be a little confusing because usually when we declare or instantiate a class, it would be something along the line of person X equals to new person parentheses, right? So so far we've never seen this before. And the left-hand type is called the reference type, and the right-hand type is the object type. So the left-hand type refers to what type X is, and the right-hand type refers to new person memory that X points to, or we call them references. Any reference can point to a subclass of the reference type, so it is valid for X to point to student. And know that if it is not valid for a student reference to point to a new person, okay, it is not valid for a student reference to point to a new person class. This is because not every student is a person. So every person, right? And like, I know that doesn't make logical sense, but like the classes are set up in such a way that it works from left to right, but it doesn't work from right to left. So it's not, they're not the same. Okay, so you can't reverse the order of that. I'm trying to think of, I think this would be the commutative. We're talking about math. All right, so this property is kind of, so polymorphism is kind of it's kind of isomorphic to the, I think commutative property in mathematics, kind of similar in this sense. So order is important in setting up reference types. The first rule of polymorphism is that behavior depends on object. So what do I mean by that? Polymorphism tells us the behavior of code when the left and right hand types are not equivalent. So in Java, as well as most other languages, the behavior of code depends on the object that a reference is pointing to. So look at this example of the code. In this case, you have, gonna just see. Okay, so you have animal X equals the new cat. And so the left-hand side and the right-hand type are not equivalent. And so what is the behavior for this, this piece of code? Well, it depends on the object that a reference is pointing to. And if you remember from our previous slide, just look it up right now. We call the left-hand type the reference type, and the right-hand type the object type. So we're looking at this example, animal X equals new cat. Animal is the reference and object is the cat, right? And as the first rule of polymorphism states, the behavior of code depends on the object a reference is pointing to. So what it's saying is the behavior of code depends on the right-hand side of that equal sign. So in this case, the object X would behave similarly to, or one would expect that it would behave similarly to the cat object, the cat class, excuse me. So when you do x.makeSound, so notice how both the animal and the cat class have a makeSound function. For the animal, when you execute the makeSound function, it will return grr, right? And then for cat, when you execute the makeSound function, it would return meow. So the two outputs are different. So what about X, right? When you call on the makeSound function of X, it will return meow because of the first rule of polymorphism. So that is a very basic example of how this rule affects results. And right, in the same way, when you call on when you instantiate X, it's a new animal, right? So this time the object, remember the left-hand side is reference, the right-hand side is the object. So this time the object is animal class, or just animal. And so when you call on that function, it's the same function as what we called before, but this time when you call on it, it will return grr, since it's pointing to new animal. Okay. And I don't see any questions in the slide, so I'm going to move on. Okay, so the second rule of polymorphism is that compilation depends on the reference. Now, the reference, like we talked before, is the left-hand side of that equal sign. So let's find an example. Okay, so consider the cat and dog classes below. Okay, the two commented lines. So c.makeSound and d.makeSound. The two commented lines, those are the two commented lines. Do not compile right now. So Java will not even allow you to run the code since the animal class does not have a makeSound method. Does everyone see that? The animal class is empty right now, so it does not have makeSound method. So it's not going to compile if you run that two lines. Even though C and D are actually a cat and a dog. So I know there's a lot of code on the side, but right below public static void, you'll see that animal C is set to new cat, while animal D is set to new dog. Right, so if we want to figure out what the reference and the object are for those two lines, you'll notice that the reference is animal and for both lines. And for the first, it's the object is cat. For the latter, the object is dog. So C and D are actually a cat and a dog. But even though those objects have a make sound method, compilation depends on the reference type. Okay, I'll repeat that one more time. Compilation depends on the reference type, which is the left-hand side. So the two commented lines, right? C dot make sound and D dot make sound will not compile because the class animal does not have a make sound function. So an easy way to think about this, so just remember the first rule of polymorphism involves the right-hand side. So for those of you who are right-handed, you can think of it as like that. So the first is your right hand. The second is your left hand. Okay. And the second rule of polymorphism involves the left-hand side of that equal sign. So it's the reference type that matters for the second rule, and it's the object type that matters for the first rule. That's it for the two rules of polymorphism. Now we are on to some more complex uses of this concept. So polymorphic use of collections. What does that mean? So given multiple objects that share a supertype, it is possible to put them in one collection that is generic on the supertypes. Note that this is true in general. Any method that takes a type automatically accepts objects that are subtypes. Okay, I'll repeat that one more time. Any method that takes a type automatically accepts objects that are subtypes. Okay, so looking at that example. Okay, so you have an array list, and which, we covered it in the previous lesson. That array list can only contain elements of the same type. Okay, and that's the one you put in the little triangle bracket. So in this case, it's animal. So array list X is equals to new array list animal. So when you add a new cat, since it is extending animal, so it's a subclass of animal, it does compile. So this line does compile, and it is valid. Similarly, when you add a new dog, it also will compile successfully because dog is also extending animal in this case. And so you will likely see this type of syntax more often as you become more and more advanced in Java. And one of the, I'll give you an example in the chat actually. Hold on. So one of the data structure, which hopefully we'll cover later, is called a, but yeah, that's the polymorphic use of collections. And if any of you want me to go over the first two rules of polymorphism again, feel free to drop it in the chat or just unmute and tell me to do so, because we're going to have a few p-set problems that we're going to do involving polymorphism and a little bit about inheritance. So let's go over the first p-set. Okay, actually, I think I'm gonna do a review of the first two rules first, because I think. So let me just go over this. This is very important. Okay. So reference type must be superclass of object types. Okay, I'm just repeating these two slides because we're going to be using this concept for the P sets that I found. Okay, so consider the valid program. Person X equals new student is valid. The left-hand type and the right-hand types are not equal. And why? Well, because the left-hand side is the reference type and the right-hand side is the object type. And the right-hand type refers to the new person in memory that X points to. Any reference can point to a subclass of the reference type, right? The keyword here is a subclass. Any reference can point to a subclass of the reference type. So it is valid for X to point to a student. Note it is not valid for a student reference to point to a new person because person is not a subclass of student. Okay. Right, the first rule of polymorphism, again, if you want to remember it, if you're right-handed, your right is number 1 and your left is number 2. Right, so for the first rule, it involves the right-hand side, which is the object type. Okay, basically it says that the behavior code depends on the object that a reference is pointing to. So the behavior code follows the object type. And the second rule, which involves the left-hand side, and it states that compilation of code depends on the reference type. So compilation code depends on the left-hand side. For example, if you want to call out a function, you have to make sure that the left-hand side, the reference type class contains that method. Method and function are used interchangeably. Okay, so now the first P set, okay? And I'll give you guys, since this is the first P set about polymorphism, I'll give you guys about 5 minutes to do this on your own. And if you have, so I will not answer questions first. I want you guys to try to figure this out yourself. And then I'll give you guys the answers at 3:50. Okay. All right. So the answer is for the first one. And you guys can check if you got it right or not. But the first one, the sum of 2 numbers should be 50. For the second one, the sum of 3 numbers should be 120. Okay. And the reason being, the method have different parameters, even though they're called the same and they're from the same class. The reference type of A, the variable A, lowercase a is capitalized A, the class A, and the object type is the same. So the variable name, so the 2 methods are distinguished just solely based on their parameters, and that's how you know which function it was referring to. All right, so the next, okay, we don't have that much time. We only have 9 minutes left, but for the second question, I want you guys to try to find an error from this code. So it's a pretty short, there's only about 9 lines of code. So I want you guys to try to figure out what the error is. And there is indeed an error. Okay, so the error here may not be obvious because when you're looking at the print line, it's saying that one is sum of 2 numbers, while the other is sum of 3 numbers. But actually, the second method is exactly identical as the first one. Yep, the parameters, the orders of the orders of the parameters are different, but they have the exact same method. The name of the method are exactly the same, and the number of parameters is also the same. Both have 2 parameters. So they're not distinguishable. Okay, so that's a duplicate method error. And yeah, okay, so the third p set, I want you guys to tell me what the output of this piece of code would be, given no error. Okay, I'll just announce the answer. So the output is 1 and 2. Okay, does everyone see that? Right, a.m1, the first method, and then you have the second method where there's 2 parameters. So it's the same as the first p set. The reasoning is the same. Okay, the second. All right, the fourth p set. What is the error? And I'm not going to pause this time because we're running short on time, but there is a duplicate method error in the above code. So it's exactly the same as the second p set. Okay. But the code will compile and the output is 1. Okay, so what is the output for this one? This one looks a little different. So first of all, will this code compile at all? So let's look at the, I can look at it more closely. So there's 2 classes now. Class B is a subclass of class A. Okay, and you have 2 instantiations happening. Both are containing the same types. The reference and the object types are the same for both A and B. The first line of outputs can be M1 method in class A. And the second one is going to be M1 method in class A again, and then M1 method in class B. And then M1 method in class B again, and then M1 method in class B for a third time. All right, p set number 6. For this one, the output is going to be 2 and 1. Okay. So we're only 4 minutes left, so I'm not going to do that much explaining for this. But if you do have questions, you can either put it in the chat, or just unmute and stop me. Okay, so p set 7. All right, so you have class B extending class A. So class B is a subclass of class A. This time you have the reference type being A and the object type being B. So the 2 types are different. All right, so if you remember the first rule of polymorphisms, remember if you're right-handed, first rule involves the right-hand side of that equation, which is the object type. And so the behavior of the code will be the same as object, as class B, which doesn't contain, but the compilation of the code, which is the second rule, the compilation of the code involves this involves the left-hand side, which is the reference type. So it does, if you run a.m1, it does, so A does have M1 as one of its methods, because according to the second rule of polymorphism, the left-hand side determines whether it will compile or not. But the parameter type A is not applicable for the arguments, right? It's not the right parameter. So this time it's not gonna compile correctly. P set 8, this will not return any error. The above code will be compiled successfully, and the output is given below. Okay, so it's 1, 2, 3, 1, 2. That will be the output. All right. So I think that's it. Thank you for coming, guys.